All right, we're back. I'm going to take a look here. We're running about 2500 kb versus I run about 5000 normally. And let's see, 10-second test, 0% dropped frames. Everything look better? People hear me? So on and so forth. I can tweak levels if need be. Yeah, I think we need a little bit more microphone here. Maybe y'all can hear me a little bit better then. Awesome. Cool. Thanks for checking, and I appreciate that. So, back to where we were. We were talking about this radio. Let me put my rolling papers up. Cool. Awesome. Yay. So again, fuck you, Comcast. Can't stand this internet, but it's the only game in town unless I want to do like 25 megabit down, 2 megabit up, CenturyLink DSL, and that's not an option. That would be sad. So, let's go into the Kenwood TS50S. This was made in the late 90s, early 2000s. This is a 100 watt HF transceiver, so shortwave bands. It's in perfect working shape. And I saw this about 5 minutes after I walked in, and I was like, hey, how much for the TS50S? Because normally they go for like $450, maybe $400, something like that. And the guy was like, so I've got the radio and the tuner, and it's $75. And I looked at him and I was like, $75? And he said, yes. And I said, sold. Didn't even ask if it worked or not. Because even broken, this thing is still worth $200. So it's a perfectly functioning 100 watt shortwave rig. I've already tested it. It worked great. And the other bonus is that it comes with the Kenwood AT50 automatic antenna tuner. So this is a device you need when you have just like a random length antenna and you need to match it properly to the radio. So I got both of the radio and the tuner for $75. Again, this was an estate sale. The ham that owned this passed on, and his family just said, bring it up to the HAMFEST and sell it off for whatever you can get for it. I don't know why they didn't search eBay first. Because this thing, I've looked it up, there are current running auctions with a min bid of like $400 for this pair. So I got it for 75 beans. And so I'm super tickled about that. We have a use for this. It's not just radio hoarding. Currently I use a low power 10 watt radio in my truck for mobile shortwave type stuff. And this is going to be the replacement for that radio because the radio that's currently in the truck is basically my backpacking radio. It's very compact, but it's low power. Not really the best solution for operating mobile because you got lots of DC power available. You don't have to keep it down to 10 watts like I do. So this is going to be a 100 watt radio. It's 10 times louder. And it has this tuner, which will help very much because short mobile antennas require some sort of matching network or tuning in order to work. So I can just basically hook this up to a, y'all may remember the big like 9-foot CB whips that people would put on their cars back in the day, or like the big antennas on the back of like state police cars. Those were all like 8-foot long, just whip antennas, just a piece of metal. So I can switch to that. I can run the radio through the tuner up top, and that'll match everything up automatically. I just hit one button here and everything works, and I'll have a great signal. So I'm very excited about it. And I mean, as you can tell, it's a small, compact radio. Like if you compare it to my 746 here, I mean, it's kind of hard to tell, but even with the perspective there, it's about 1/8 the size of my main base radio here. So that's going to be very nice for operating out of my truck. Be able to take it camping, stuff like that. Just hook it up to a battery, whatever. It's going to be a whole bunch of fun. So that's the real joy. After I found that, I didn't care what other deals I snagged or sniped or didn't, with 2 exceptions, which we'll again get into in a little bit. But after that, I just kind of said, well, I've already won for the day. Let's just kind of pick up neat shit that we want and kind of check out good deals. And the deals didn't stop coming. So let's move on to some little piddly things that I got. Some cool things that you might want to look out for at HAMFests if you ever want to play radio and get some good deals. This little box is pretty neat. This is an MFJ receiver antenna tuner. So this does kind of the same thing that the automatic tuner for the Kenwood does. It matches the radio to the antenna and so on. But this is meant just for receivers. You can't take any power through this. But what I'm thinking for this, and it was $5. You can see the carefully created price sticker there. This is going to go in front of one of the little $20 SDR sticks. If you've ever messed with those and tried to get one on the shortwave bands with like a big long wire antenna, you know that they overload terribly. And they get like AM broadcast interference and all kinds of shit like that. So this is basically going to ensure that only the signals that I want to get through are going to get through. You see you have a knob here. It's a nice clicky switch for the various shortwave bands. Come on, focus. Break focus and try to bring it back. Yeah. There we go. There we go. So it has a nice switch for the shortwave bands. You can hook up two receivers and 2 antennas, and then you have a little tuning capacitor here, and that'll basically let you peak the signal and get only what you want and reject what you don't, which is mostly going to be AM broadcast on those terrible things. And OG style, as classic 80s MFJ goes, it's all RCA jacks, which is fine if you're just running receivers. We're going to take a look at another radio later on that has an RCA jack, and it's a transmitter too. But that's because it's just so freaking old. So yeah, you just make up some RCA cables to hook a couple antennas to this. You might have like a long horizontal wire, and then you'll have like a vertical that's going up a tree or something like that, and then 2 radios that you can switch between. And yeah, Bobby, you got to have some sort of input tuning network on those SDRs, because they are literally and like this is literally not teenage girl literally, but they have a direct connection from the antenna input into the ADC converter of the SDR. So they will take all sorts of subharmonics. You'll hear like AM radio stations every 10 kilohertz all the way through the shortwave bands that just overpower everything else, because you're getting so much more energy from those local AM stations than you are the much weaker shortwave stations. So you need a filter on the front end. There are various kind of low power antenna tuners out on eBay and stuff. They're like 25, 30 bucks or so. But I found this and like just thought instantly this would be perfect for a cheap SDR stick or something like that. So yeah, we're gonna hook this up probably in an upcoming stream, and I'll just hook it up to my 135-foot wire out there. And focus, you terrible camera. I wonder if like my camera's dirty or something. I don't know how it does focus sensing. Anyways, so this will be a great little accessory box to kind of help a little cheap little receiver go, and that would be good for like a little portable AM receiver or a portable shortwave receiver or something like that. That has problems with like overload. You can kind of peak the signal and get only what you want and kind of ignore like a bunch of the other stuff that's just bleeding through. Let's see, what other goodies do we have? Keeping on the antenna tuner angle, let's take a look at our next grab. So this is an MFJ Versatuner. These are super common. Tons of hams use these for kind of their first antenna tuner. Let me tweak my angle here. Boom. All right. Got this for $15 off of that same estate sale. This is meant to transmit, so you can put up to 100 or 150 watts or so power through it. You got a couple of variable capacitors here, a switched inductor, and then an SWR meter, so you can test the match and see how good your adjustments are to matching the antenna to the radio. Very nice. It's a pretty expandable unit. So you have a bypass thing, which doesn't go through the tuner, so you can just hook an antenna that you know you'll never need to adjust the tuning on straight to this. And then you have two coax lines that you can set the tuner through. So coax 1, coax 2. And then if you want to bypass those, you get a 1 and 2 direct. It also has just like a ladder line feed. So if you feed stuff with like the 400 ohm or the 300 ohm kind of twin lead stuff, you just hook it up there. You got a nice binding post for ground. And if you just want to use a random wire, you can just put it on this binding post and you can switch over to those two. Those two share an input. The random wire input just feeds one side of the balance line, and then the other side is connected to ground. So this is really cool. The biggest thing that I got it for is because it's so small, I'm probably going to hook it up with that backpack radio, that ICOM 703 that I was talking about earlier. This will let me just basically take any wire I want and throw it up in a tree or string it out between a couple trees, and then I'll be able to match it properly to my radio wherever I'm operating, saving my radio from being blowed up. And it's about the same size as that radio too. So this will be a nice compact package. These go for, they still sell these. One indication that this was like a early to mid 80s setup is the wood grain here. MFJ didn't do that past like 88 or so. So this is pretty vintagey. It's nice and old school. Still works great. I've tested it. It does all the necessary functions just fine. So yeah, $15. Only thing that sucks is that the meter is not lit up, but I could probably put a couple LEDs in there and, you know, do a little DC input. May not even mess with it because, you know, as I said, you know, I'm going to take this backpacking and camping and stuff like that. So I don't want to mess with a bunch of extra wires and power sources needed. So MFJ 941 antenna tuner was snag number 3 we're up to at this point. I guess it was 2 because I bought both of that and the Kenwood at the same time. Let's see, what else did we get? This is fun. This is a whole bunch of fun. So I've wanted one of these things for years and years and years. And I've always eyed them up at the HAMFEST, and I never actually just grabbed one. So this is a Motorola desk mic. You would see this on the desk of like a police dispatch or something like that. They're all over the used market. There's just dozens of them at every HAMFEST. And for some reason, I never actually picked one up, even though I've always wanted one. Pause for a sip. So these are excellent sounding microphones. They have 2 very joyful, wonderful buttons on them. One side is push to talk, and the other side sends what's called a tone out signal. So if you've ever heard like an old school police scanner, you know, back before digital trunking and stuff, they would sometimes send 2 tone sequences. So it's like, dee-doo. What that was firing off a bunch of pagers, actual voice pagers, on all the like firemen's or cops' belts or whatever. And they would switch the radio on, and then after that, you would send out the dispatch and say, hey, you know, we've got a stabbing at like, you know, 420 Main Street, or hey, there's a fire at 666 First Avenue, whatever. So that button would send out the tone out pair, and then you just hit push to talk to actually like send your voice signal out and chat on it. Super well built, steel base, solid, awesome like 70s design on these. You know, the mic element is up here. I've cracked it open, it's flawless inside. The only weird thing is that it has a very strange, focus on that, yeah. It's like a weird 6-pin staggered jack with some retention clips. That'll get snipped off, and I'll put a proper microphone plug on here so that'll actually plug into my 8 pins up there, most likely. $5. Very happy to spend that on this. These are very cool units. And so yeah, I'll have a nice desk microphone. Of course, I still have my big Shure boom microphone and all that. But this would be nice for kind of more casual operation where I don't want to pull up the whole audio chain and everything and kind of, you know, wire all that crap up. I can just plug this into a radio and go. And again, I love the action on those. You see how it pops out? Just very, very, I don't know, late 60s, early 70s design, and these persisted for about 20 years or so. And they're very well regarded. People like to use these a lot. Cool design, good microphone, $5. So, yet another snag. Check my clock and see how we're doing here. Trying not to bump my desk too much because I've got an intermittent mic connection and I need to fix that later, but we'll get to that soon enough. Here's a fun side grab. It's not tinsel, it's not rope. This is grounding braid. Most importantly, this is avionics spec. This is an avionics wire company that makes wire and cabling for airplanes, or at least they did back in the 70s or 80s, about that era. Maybe the 60s, I don't know. I really like the design here. Just very technit, yeah. So this is ground strap. You would use this to like connect pieces of your gear back to a common ground bus, so that you don't get like ground loops and hum and stuff like that. It's not the same as the copper braid out of coax cable. It's made of even finer things. It's almost like a rope. Very, very flexible. Like, it's super flexible, and it can take thousands and thousands of flex cycles before it gets fatigued out, which of course is important when you're wiring up an airplane. So I got a roll of this, and I can only estimate that there's a couple 100 feet of this on there. This stuff was probably $3 a foot back when it was first sold. Yeah, it does look kind of foamy, and it has a very cool feel. It's very, almost feels like a woven fabric. Of course it is woven or braided together, but it doesn't feel like standard copper braid. So yeah, I got this like a 99% discount per foot versus what some company charged an airline manufacturer to wire up their planes. So $5 for a couple 100 feet, something like that. Very nice snag. I'm excited about this, and we're going to redo all the grounding for all the radios, especially when I get my new radios in a couple months, with this stuff, and make sure that everything's in good shape. You just take this and you probably like crimp some terminals on the end, some like ring terminals, and then lock that down to a screw on the back of the radio. All ham radios have like just a basic ground screw that just locks into the chassis. So you just screw that down and you're good to go. Some other stuff like my mixers and stuff, I generally just like back out one of the screws on the back of them and then scrape off the paint a little bit and use a star washer, and that grounds them pretty effectively too. So very cool stuff. Caught my eye, and saw the price, and I was like, that's mine too. So we've gone through that. Let me stretch just a little bit. And if you caught the last stream, you saw me talking about antenna rotators and the specific type that I like. And lo and behold, I found another one. The Venerable Alliance U100 rotator. Did not have the control box, which is fine, because I'm not going to be using the little twisty knob control boxes to actually control this. I'm going to build a computer interface for it to send voltage to the appropriate wires and spin it left or right, or in this case, up and down. So since I have two of these now, we're going to have two of them installed. The other one is going to be installed vertically like this, and the main mast is going to go through this tube. This is going to be locked down to like a mounting plate that's anchored to the ground, and then this will turn around and actually spin the antenna in different directions horizontally. But then this unit, I need to build a little adapter plate, and we're going to mount it sideways. We mount it sideways because these have one miraculous aspect to them. The hole for the mast goes all the way through. So what this means is that you can take like a 6-foot dowel or a fiberglass mast. You want to use something non-conductive pretty much. You run it through there halfway so that there's 3 feet out on each side, and then you mount an antenna on each end of that. And then when this turns, it's actually going to tilt them up and down. So I can tilt all the way through 180 degrees, which is cool because when a satellite's passing straight overhead, the track on it is pretty straight. Like the higher up it is, the less curve there is. So if it's coming overhead at like 90 degrees peak angle or even like 80 degrees peak angle, the track as you see it is pretty much a straight line from either southwest to northeast or southeast to northwest or whatever. So what you can do is you don't even have to turn the antenna. You can just follow it going up, and then as it hits that kind of zenith angle, you just keep rotating and you just go all the way through, because the antenna doesn't care if it's upside down. So it's actually very easy to track the super high approach ones. You just point it in the direction that it's coming, and then you can flip it around and catch it as it's leaving. Very cool. And like I said, we're going to have computer control for all this. I've got to build a rather complex circuit. It's got to take basically serial input. There's a certain protocol, and then the computer tracking program basically says, okay, turn to bearing 185, elevation 12. And it does that every few seconds. Turn to bearing 190, elevation 17, so on and so forth. And then the controller has to decide when to turn the antenna and how much. So there will be a little bit of Arduino code in there. Fortunately, somebody's done all the hard work, and they actually just kind of have a plug-in module. You just load this code up, tell it what kind of sensors you're using for like bearing and the elevation, and then you just let it do its thing, and it tracks things automatically, which is important because when you're working satellites, you have two radios. Let's say those two, because those are the two I use. Two radios to tune, two rotators to turn, a push-to-talk button. You got a microphone to deal with. You have to run headphones because satellite stuff is full duplex. So you hear yourself coming up and coming down from the satellite. You have to do that to make sure that you're actually the signal that people are listening to, because there are dozens of people trying to transmit at the same time, and you need to find out if you basically won the battle or not. So you have headphones on, you're talking on the microphone, trying to see if you're making it through, two radios to turn, two antennas to turn, and you're also typing and trying to log all this crap at the same time, which means that you need about 6 hands to 7 hands if you're doing everything manually. So the goal is to automate everything you can. So we're going to automate our radio tuning, so they'll keep track with the satellite frequency, because there's Doppler shift. As it comes over the horizon and comes into you, it's going to start at a higher frequency, like 1% higher or something like that. And then it's going to drop in frequency. Same thing as like a train passing you. But it's at RF, so that means the shifts are much higher. But the effect is the same. It's just multiplied by 1,000. So you have to tune your radios and tune one radio down and turn the other up as it approaches, and then just basically continue doing that. So you definitely want a computer, because it can automatically calculate how much you need to tune up or down to be dead on at the satellite, which is really cool. So I'll automate the radio tuning, I will automate the antennas, and I'll have a headset on and a microphone in front of me. So that means that all I need to do is basically talk and operate the keyboard and mouse for the computer for logging contacts, and we should be in business. So I was very excited. This was $50. I was happy to pay that price because these go for about $150 or so on the used market. It appeared to be in pretty good shape. Somebody at least cleaned it up and did the basics. So that was cool. So yeah, I'm excited to get this thing wired up, and we're gonna have a big spring project while I build up my new satellite antennas. It's definitely not something that I can knock out in a week. There's a lot of engineering. I've got to buy materials. I've got to build that control box for these rotators, buy new antennas because I need lightweight ones. I've currently got some very heavy ones up, and they just get torn down by the wind basically. So yeah, that's going to be a big spring project. Hopefully in about a month or so we will make significant progress, and then we're going to have some real fun while we play on the satellites and we talk to people real time. It's super exciting. It's the most exciting thing I've ever done in ham radio, and I'm excited to share that stuff as soon as my station's set up. And it's a little bit lower stress. I can work them sort of now, but I only have a rotator that spins the bearing. I don't have one that tilts it up and down right now. So I have to choose which passes I actually work carefully. If they're too high overhead, I'll lose them in the middle. And if they're too low, like they're too far off, then I just get kind of shitty performance. But this will make things a lot more consistent. So, Alliance rotator, $50, a splendid deal. Let's see, we have 15 minutes to go till the hour. Let's talk about power supplies. Big boxes, heavy boxes. Bought this from another fellow. This is not the estate sale. He was just selling things off. Just a random vendor. This is a 12-volt power supply. I was shopping for power supplies because I've got an older power supply made by Alinco, who is known for making kind of discount ham gear. A lot of people have, kind of discount stuff. Just one sec, Bobby. But I was looking for a new power supply and I found this one. To answer Bobby's question, receive antennas are a lot easier to do because you can just basically add a preamp to boost the signal up. The QFH antennas, as you mentioned, those are quadrifilar helix antennas, and you basically, it looks not unlike a DNA strand. It's like two curly elements that follow each other up, and then you basically aim those up, sort of in axis where the antenna is. I'm going to have just a couple directional beam antennas that I'm going to buy. I'm going to buy like a Cushcraft and a Diamond or something like that. So I'm going to just aim those straight at it, and I should have more than enough signal to work with. But for receive stuff, you can use fixed antennas and just kind of get them up in the air and make up the difference with a preamp. Ideally, you want the preamp at the antenna because if it's on the end of 100 feet of coax or whatever, it won't really help that much, but it'll still help more than not having one. So receive is pretty easy. One thing I've actually seen somebody do with great success is they bought two just shitty $25 outdoor TV antennas with like 3 or 4 elements, a couple of VHF, a couple of UHF. Not designed for satellite work at all, but what they did is they took 2 of them and then turned them vertically so that the elements were going up and down, and mounted them back to back, but tilted them up like 20 or 30 degrees. So you had 2 antennas, let me find, let's use a dab tool and a pipe for that. They were aligned pretty much like this, and they just faced north and south. And they're not super directional antennas, so they just kind of one picked up anything in the southern half of the sky, and then the other picked up anything in the northern half of the sky. And they just hooked that up through a 2-way cable splitter and run that to their like SDR or whatever, and had tremendous success. So I'm kind of curious about setting up a simple setup like that. Yeah, one tab tool. It's got a little dirty, but haven't used it in months, but it's there. Yeah, so just take a couple directional TV antennas and mount them back to back and aim them north and south and tilt them up like 25 or 30 degrees. They'll still cover down to the horizon, but they'll cover up to like 70 degrees elevation. So you get actually really good coverage of the sky as the bird goes over. And most of these satellites that we're dealing with here, they don't orbit the Earth around the equator. They actually do what's called a polar orbit. So they launch them just in an orbit that's basically north-south. They just orbit the poles, hence polar orbit. And then the Earth rotates underneath them. So they're not really moving relative to, like, if you looked at the orbit of the Earth around the sun, they're always in a fixed position with relation to the sun. But the Earth is rotating underneath them. Most of them, like the low Earth orbit satellites, they have about a 90 to 100 minute orbital period. So they'll be at the same spot in their orbit about every hour and a half to hour and 45 minutes. So if you look at an orbital map and like all the predictions, you see that they will go like, there's generally 2 different situations at the height that our ham satellites are at. You'll see either a 2-pass kind of afternoon or a 3-pass afternoon. The 2-pass afternoon is when their first time around the Earth is like they'll be like a little bit east of you, and then you'll rotate underneath them and pass them, and then their next orbit will be to the west of you. So you would have 2 usable orbits on kind of that afternoon, and then after that, the Earth has to come all the way around and catch them on the backside. The other setup is the 3-orbit afternoon, where they're farther out on that first orbit, so they don't have a peak elevation beyond like 10 degrees then. That's not that good, but you can still work a contact or two. But then the 90-minute period means that the second orbit out of 3 is going to be right overhead, and they're going to come over at like a 70, 80, 90 degree angle. And then the third orbit will be off to the west there, and it'll be another one of the low passes where you can maybe work 1 or 2 people. So there are a couple of different situations that you have to look for when you're dealing with the satellites. Like, what's it looking like today? What's my antenna setup looking like? What's the schedule like? Generally, they're set up to where you can get usable passes during daylight hours. A lot of them are extremely solar powered, meaning that they don't really work that well when they're in the shadow of the Earth. So if it's nighttime and they're coming back down over the poles, you may not get a good signal. Some of them pop down to a lower power level and so on. But when they're in sunlight, generally they're operating at full tilt, they're loud, they're easy to hear. So that's why people generally try to work the satellites, not only because of that, but because people are awake to talk to during daylight hours a lot more. And yeah, I was looking at like purpose-built satellite antennas from like M2 and stuff like that, because I'm buying like the ICOM 9700 and so on specifically to work satellites with a couple other purposes. And I was like, well, if I'm spending $2,000 on the radio, maybe I can spend a little bit more on the antennas. And I was looking at the market, and it was going to be like $700 to get 2 antennas, because you talk on 2 different bands. You talk on like the 2-meter band and receive on the 70-centimeter band, because you're doing full duplex, or vice versa. You talk on the 70-centimeter band and receive on the 2-meter band. So you need 2 antennas for 2 different bands that have to have separate feed lines going to them. So you're talking about expensive costs for the coax and all that, and you have to point them. And it was looking to be like $700 for a pair of high quality antennas, and then another $200 for the feed line, and then the rotator. If I wouldn't have done the little homebrew jobby that I'm about to do with the like hacked old Alliance rotators, you're talking about $750 for a Yaesu rotator that can do both azimuth and the elevation. So I was like, oh, I'm gonna be spending another $1,500 on like all this. But I found some cheaper antennas that should do nearly as well a job, so I'm gonna buy those. We're looking at maybe like $150 or $200 for both of those combined. I already have the wire and the coax needed for those. And then I've spent a total of $150 for my rotators. I'll probably spend another $50 on like relays and an Arduino and some serial port interface type stuff to get that working. So I've knocked $1,000 or so off of the total outlay of my satellite station. So I'm looking forward to that. I don't know why I took this down off the bench. We got sidetracked talking about birds. So this is a 20 amp power supply, not too much to speak of. I got it for $20 just because the guy just wanted to get rid of it. It's nice, and it's actually still my backup power supply. And I'm not going to show a photo or a live picture of the other power supply that I got, because it's currently under my desk and it's kind of a rat's nest of wires, but I've installed it. So let me pull up a photo of it and we'll chat about it a little bit. So that was a 20 amp 12 volt power supply, and what I managed to find at the HAMFest from, again, the estate sale of the ham that died, they had one of these things going. Let me switch over to my thing with the monitor. Yes, okay, so this is the Astron RM50M power supply. This is a power supply that is rated at 50 amps of 12 volt power intermittent and 37 amps continuously. It's what's called a linear power supply. So we've talked about switching power supplies a bit on the stream before. They're noisy as far as RF goes. They spit out harmonics and all sorts of stuff like that. This is what's called a linear power supply, which means it has three basic components. You have a transformer, which is the bulk of the weight of this thing down there. This thing weighs 46 pounds as shipped. So it was a big pain in the ass to kind of huck it around. I'm not rack mounting it. Those rack mount eyes are a trap. You will bend rack rails on anything you put this in unless it's a 4-post. So I just have it on a milk crate. So the bulk of the weight is in the transformer, which takes 120 volts coming in, knocks it down to about 15 volts AC. Then you have a rectifier, which are basically 4 very high current diodes that take your 15 volt AC and turn it into a sort of pulsing 15 volt DC, because all the radios here on the bench run on DC. And then you have a filter capacitor unit, which are some big old capacitors. And when I say big old, these things are literally the size of the Solo Cup or larger. They're meant to handle lots of current, and they smooth out the power. Let's see. Rectified AC. I'm always really bad at typing whenever I'm being watched. Happens at work too. So yeah, this is a basic rundown of what AC looks like after you run it through a rectifier. You see that it's all positive here, but it's kind of lumpy. And the filter capacitors smooth that out into just nice, smooth DC. It doesn't vary in voltage or anything like that. And that's what actually feeds the radios. So yeah, again, we have a Astron RS50M. I don't know what the difference is. Mine actually does not have the black faceplate. It has a beige faceplate that says Tate Radio. Tate was a company that installed two-way radios for a lot of commercial networks. Like say you ran like a taxi dispatch or something, Tate would install all the radios on contract for you and maintain them. So mine's actually branded Tate Radio. It was probably pulled out of some commercial install, maybe a cop radio install too. But at any rate, I got this wonderful power supply 5 minutes after I found that power supply. And I bought both of them because I'd obviously bought that one for 20 bucks. And I got this one from the estate sale for a grand total of $30. These things retail for about $3.59, brand new. And then you have to pay $100 shipping because the thing is so damn heavy. So let's say I got 90% off that. The shack is currently running off of it. It's 100% fanless. My previous power supply, you might have heard it on the stream before. Every 5 minutes, it would spin up the fan for 2 minutes because it had a temp sensor, and I was like, I'm getting a little warm. That was compounded by cat hair. Thank you, Nargle. And it was just this annoying kind of periodic fan spin up here in the shack. Now the shack is basically silent, barring like my radio exhaust fan and so on. So I'm much happier, and we have enough power here to literally arc weld things, which we'll try not to do. So that was yet another amazing deal that I found there. So yeah, it's great to have everybody today. I see a couple new names that haven't popped on. Nice to see you, John. And Butcher popped in there a little bit ago. I don't know if he's still kicking it, but hi, Butcher. Bobby's carrying the chat. Bobby gets the gold star. If I could tip bits to Bobby right now, I would. So we're at the top of the hour. I'm going to take a 5-minute break, and then we're going to go into even more stuff that I bought. I got a few more things that I want to show off. I bought another radio that I think everybody is going to really like, especially if you like 60s kind of electromechanical, aesthetic-y type things. So stand by for just a few, and we'll be right back in about 4 or 5 minutes. Still work. The microphone still works. Yeah. I gotta fix that bad connection. 1 second. That was definitely just tobacco you saw on the camera. We back. I promised 5 minutes, but actually deliver 3. Heyo. Insert jokes here. So, welcome, birds. Nice to see you hop on. We are not done with show and tell. We've got some stuff to go through. To recap, for those of you just joining us, we got an awesome ham radio shortwave rig for super cheap, 75-80% discount at the HAMFEST. We've got an antenna rotator for a good market price, about half price of what they sell for. Various little antenna tuning matchboxes. My new workout weights, power supplies, went over those a little bit. And I did buy more radios because I saw good radios. Did I do it? Yes. Emote spams make me so happy. So this next one is groovy. This next one is just freaking cool. Let me park my keyboard 1 moment. Get some nice space going on here. Yes. So this next one is from the venerable Heathkit Manufacturing Corporation, active from the 60s through the 90s, and then they died, and then they came back, and we're not going to talk about their comeback because it was shameful. We might actually a little bit. But this bad boy is the Heathkit, what is it, HW2036. This was, it's actually a really sad story behind this one. So I saw a booth with a huge stack of beautifully kept radios, and there was like an older fellow that was wheelchair bound and obviously having problems, and then his family around him. And I talked to his son, who had explained that his dad had recently advanced to a stage of Parkinson's that rendered him no longer able to enjoy the hobby. And he was very, like that in the chair, couldn't really interact too much. So the son was pretty much running the show, and he was like, we're just selling off Dad's radios. There's no set prices. If you like something, tell me what it's worth to you, and I will tell him, and he will either nod or shake his head. So he had a bunch of expensive rigs. I didn't even want to play with those because I'd already gotten that super sweet Kenwood. So I was like, as far as like actual useful radios go, modern-ish. I'm stocked up and I'm happy as far as this swap meet goes. So let's look for the weird stuff. And he had one of these up there. So yeah, this is late 60s, early 70s build. It was active for a few years. Let's see if we can get some closer zoom in on this. You gonna focus? Yeah. So this is a 2-meter radio, which means it operates on the 2-meter band. It's about 144 to 148 megahertz. This was one of the first 2-meter radios out there. As you can see, it has a mobile mount. People were very excited to get radio in their cars. The previous rigs were just too big and they required 120 volts. So this is when transistors showed up and really kind of changed the game. Can we get like a zoom? Are you going to focus? Focus. That's pretty good. So this has 10 watts of output. It's a transceiver, so it transmits and it receives. It's really pretty iconic because a lot of the hams, basically the older boomer generation, they only operated on the shortwave bands because that's where the tech was best. After that, we started to see like VHF and UHF, and we went higher in frequency. The wavelengths get shorter. The parts and components get smaller values, and things are just more precision built. So this is a radio that doesn't talk worldwide, but you might talk to all the fellows around town on it, on a repeater or just on simplex, which is just station to station with no relay in the pipeline. His call sign was W0 something. Half the tag fell off when I was coming home. That's just like, standard dymo. So I'll probably take that off and clean it up because I don't have the whole thing. So it's kind of weird to just leave his prefix on there, right? I'd really like to think about repainting the case. It's got that wonderful Heathkit green, blue. I'd love to find a source for that, strip it down and redo it because it's so just kind of emblematic of their radios of this era. I have actually 2 other Heathkits, big shortwave rigs with the same color scheme, and they're gorgeous. We're going to dive into those probably as spring, summer comes on because they're tube radios. They need their whole separate bench. I need to set up a vintage desk back behind me or something, or next to me, with like no computers allowed, no tech. We just like go over there and we just chill with a microphone and the guy on the other end, without messing around with all these monitors and computers and digital interfaces and crap like that. So this is probably going to be the 2-meter rig over on that vintage desk there, and we'll just move all the cables over and say, we're having throwback afternoon. On the side, we might use a little 2P3 radio that we built a while back because it's kind of in that flavor. But this would be what we talk to people around town in. Everything works on this. It's in great shape. Comes with a nice old school Heathkit microphone that works well. When you turn this on, a bunch of relays clack. When you hit push to talk, more relays clack. When you change frequency, this was a synthesized radio, which means that it looks at the inputs here, which is my favorite part, and we'll get to in just a second, and actually generates the proper frequency that you're dialing in, as opposed to having like what was before this, which is called a crystal controlled radio. You have a little tiny piece of crystal in a little silver case, and that vibrates at a specific frequency, and then you might have 10 channels on an old crystal radio, but all they're doing is putting different channels in the circuit to make it work at different frequencies. Those were cool, but they're really hard to deal with. Back in the day when there was only 3 or 4 frequencies in a region that you might want to like operate on, it was no big deal. And also crystals were like 50 cents a piece back then because they were much more commonly used than today as far as custom crystals go. So if you wanted special crystals cut for this, you just used to send mail to a guy in 1971 or 66 or whatever and say, I need a crystal for 146.55 and 147.21, whatever the active frequencies were in your area. And that way you could just flip 1, 2, 3, 4, 5 and talk to your buddies. Crystals, all kinds of crap here. The shack is a tornado because I installed the rack. Let's see, do I have some crystals bopping around here? Yeah. So, excellent question, wonderful diversion. One of the trays in my parts locker here. Yeah. So these are all crystals. They operate at different frequencies. These are mostly for the 40 meter band. So I bought a pack of these from a guy off eBay that he deals in these crystals. Focus on that by any chance? Jerkbag. Anyway, this one says 7.3728. That's the frequency that it resonates at. So if you put this in a little oscillator circuit, it will lock the frequency in really, really accurately. The only thing that will make it really vary is either vibration or temperature change. So they vibrate a little bit slower as they heat up or something like that. I forget the exact correlation, but there's a temperature versus frequency slope. Sometimes if you wanted to be really super accurate with a crystal, you put it in what's called a crystal oven. And that's exactly what it sounds like. It's a little metal box with a heating element and a temp sensor. And the thinking is that if you can keep the crystal at like 130 or 150 degrees Fahrenheit in this little insulated box and control that heater to keep that temperature as closely as possible, it may be operating off frequency from when it's labeled, but it will be accurate and it will be stable. So it doesn't matter if it's 30 degrees out, like outside the radio, or 110 degrees, because you have a heater that keeps it at 130 all the time, it's going to be very stable in frequency. Crystal ovens were a big thing, and they're still used for a lot of things, and it's a good way to get a very accurate frequency measurement when you don't have access to things like GPS, which is pretty much the easy way to do it now. You just get a GPS little receiver and you can get like 1/10 of a billionth parts per minute or something, some like ridiculous tolerance, because you're dealing with the GPS system, which it's more than anything, it's a really accurate clock. So that's what crystals are. But this radio, though it does have some crystals in there, it does not rely on them to set the frequency and change the frequency of the radio. So the synth lock, when it's lit up, the synthesizer hasn't figured out what frequency it's supposed to be on. But the coolest part is how you tell this thing what frequency to be on. And I'm gonna try to do a little bit of a side shot here. Something like that. Yeah. So you'll notice that next to each digit here, so like it says 9.43 right now. What that means is that right now it's set to operate on 149.43 megahertz. It's not actually a valid ham frequency, it's just where they got set last. But it's always 14 and then this digit, and that's your like actual megahertz count, and then .43, which is your kilohertz times 10. How you change things is those 3 levers there will circulate the digits individually from 0 through 9. So like the 7, like you just take this and it's now at 140.43. And each digit has a lever for that. So you would go to like 145.1.4, and there's a repeater here in town that's at 145.145. So what you would do is you would flip this switch that says 5, and you add 5 kilohertz. So we're now operating on 145.145 megahertz. You want to switch to the 146.52 simplex. Take this off because it's even. Go up to 146. Go to 5. Down to 2. Boom, you're on 146.52. And this controls the synth in there to do frequency division type stuff, which was brand freaking new at that point, and lets you just set your frequency. This was groundbreaking because you didn't have the just a tuning knob for the previous radios of this type. You had that fixed channel frequency selection with the crystals. So this is like, holy shit, I can operate on all the repeaters. And yeah, it's very good feel. All the switches move perfectly, and yeah, I was in love with this thing the second I got it, and I've tested it out and it does work well. So now we're on the 147.21 repeater. Now repeaters can have positive or negative offsets. which means that they listen for a transmission on a different frequency from what they talk. So say 147.21, this repeater would have a positive offset, which means that when you transmit, you want to talk on 147.81, and then you're going to listen on 147.21. And the repeater is just a big radio station that transmits whatever it hears on 147.81. It spits it out on .21. And that's how repeaters work. That's all. There's a little bit of extra like gear and stuff in between, but that's the core idea. You put one of those stations on a mountaintop, and anybody that it can hear, it'll retransmit to everybody that has like a basic line of sight to it. So you could have a little crappy handheld station down on the street where somebody across town couldn't hear you directly, but if you talk on that repeater, all of a sudden then they can hear you and you can communicate. And that's how police repeaters work and all that, and the same thing. So you would have a positive or a negative offset, which means that I'm transmitting on plus 600 or minus 600 kilohertz from whatever the so-called base frequency of the repeater is. So you just use the switch. Aux was a thing you set with special jumpers inside to have a custom offset. If, say, there was a machine that had like a 1 megahertz or 800 kilohertz offset, and sometimes that was a thing. So that was the custom setting. And then you have plus 600, which sets you to transmit at 147.81 here. SIM, which is simplex, you transmit and receive on the same frequency. This is just used for talking directly station to station. You don't use a actual repeater with simplex, with one weird edge case. So that's the simplex, and then there's minus 600, which right here, that would mean that we would transmit on 146.61. So for example, that 145.145 box that I was talking about, it uses a negative 600 offset. So this didn't have any memories, but you could set the radio to operate on pretty much any repeater. And then you go back up to 147.21. I just forget which way is up and down. You go positive offset, and you're talking on a different repeater somewhere else with a different allocation. The final thing that's really cool about this, and I've been excitedly talking about this, stand by, is that generally starting in the 90s or so, but even before then, if you had a repeater up on a mountaintop, one problem is that it would sometimes receive unwanted signals, say like interference from, I don't know, cop radios, like a taxi service radio, something like that. And that was a really big problem because it would just lock up that particular machine and not let anybody else talk on it. So what they figured out, actually Motorola figured this out back in the 60s, they invented a system called private line, or PL. And what they did is to control access to a particular radio system or repeater, they thought up this concept of subaudible tones. Now this only works because like a police radio or a VHF ham radio has a frequency response that only starts at like 200 hertz. It's not really a bass monster. There's not that really, really low end. So the voice range is like 200 to about 3,000 hertz or so on an average FM system. So it's kind of narrow band, but they had that low end to play with. So what they did is after they filtered the voice out on the transmitter and said, okay, nothing like lower than 200 hertz passes here, they then had the radio generate what's called a subaudible tone. And this is a sine wave, just a basic sine wave at a certain level that's really low down in the bass region. They start at like 67 hertz, and then the next one's like 71.2, and then 75.5, and they're like harmonically related in some way that I don't exactly remember right now, but they're all fixed percentage apart. So if you multiply it by like 111%, that's the next tone. And they just superimposed these tones on the transmit audio because the radios could transmit bass frequencies. They just wanted to filter out the low end on the voice side because there's not much like information there. They want to maximize the rate of information, so like cop dispatches and stuff like that. So they had these tones that got transmitted out with your signal, and then the repeater was configured to only repeat a signal if it contained that particular sine wave. So say we have a, like there's a bunch of repeaters here that use 103.5 hertz tone. So when you want to use those, you have to transmit a tone of 103.5 hertz on your audio. And all my new radios, they all have that built in. And this is one of the first radios that had programmable ones built in. Obviously, you could just make a little sine wave generator on a circuit board with 2 transistors and stick it in there and have a tone. But this is the first radio that had the choice of like different preset tones. So say there are 3 different repeaters in your area and they have 3 different like sets of these access tones set up. You could go into this radio, pop the cover, and inside are 3 little adjustable trim pots for the A, B, and C tone. You would hook this thing up to a frequency counter and on that audio line, and then turn the A, B, or C trim pot to make exactly the right tone frequency, 103.5 hertz or 67.0 hertz or 127.9 hertz that you needed to access a certain machine in your area. And then you could just like put the case back on, and at your turn of a finger, you could have your A, B, or C preset tone. This was super groundbreaking because people used to have to like have different little sine wave generators in the radios for all the different machines. Like here in Denver, I think there's like 15 or 18 different sub-audible tones that you need to program into a radio on different frequencies for repeaters to access all the different ones. So something like this would have a huge advantage in Denver because you could hit like the 3 most common tone groups. Like the Denver Radio Club uses this particular tone, and Rocky Mountain Radio League uses another particular tone. So with one setting, you got access to like 6 or 7 different repeaters that you could then set up here and talk on. So this was really cool, really exciting. I haven't messed with the tone generator yet, but basically every actual repeater in Denver needs one of those because there's so many radios that interfere because all the repeaters are up on mountains here west of town. So like they have a complete bird's eye view of the entire town, and they just experience a lot of RF. The whole city of Denver is blasting RF energy at them. So they have these tones set up so that they don't constantly get keyed up by like a pager transmitter or something like that. Quiet, huh? Let me see if I can turn it up. Is that a little bit better? Mic check. My levels are looking low. What the heck's going on here? Let me go ahead and crank it that way. Is that a little bit better? Mic check. Yeah, let's give it more power here. What's going on? All right, cool. We'll go for this till the top of the hour, and then I'll mess with my mic and see if it's maybe fucking up again. Awesome. Thank you for the audio check. We're about to the end of the HAMFEST haul, and then probably after the top of the hour, we're going to go ahead to this wonderful monstrosity to the right of me. I can't wait to reveal this. This is going to be a big advantage or a big improvement in the Mattyzcast over the next couple weeks. But I'm not going to spoil it just yet. Some people know what it is, but I'm going to get back into that at the top of the hour. Until then, let's look at more crap I bought. All right. What else do I have? I've got this. This is cool. So, what we have here. Did I do it upside down? I did. Sorry. Hang on. I can tell that's going to be a lot better. Yeah, my mic plug did the shitty thing. I'm going to have to fix that on the break. All right. So the next thing that we're going to look at here is going to be my new old but new to me, my very first Motorola ham radio. Obviously, it's not actually a ham radio. This is a commercial radio, probably used for like a police department, maybe like a taxi service or like some sort of concrete company, something like that. So this is a Motorola Radius GM300, made early 90s, I think. Seems to be about that vibe, about that aesthetic. Let me see if I can get the camera in there a little bit. You gonna focus? God, you're a terrible camera. I'm gonna get a DSLR before long, and we're gonna just run fixed focus stuff. Anyways, it has groovy fonts on it. I dig it. This is a radio for the UHF band, the 70 centimeter band. So we're about 440 to 450 megahertz on this radio. So we're about 3 times the 2 meter band, which means the antennas are 1/3 the size. Antenna for a 440 radio is going to be about the size of yon dab tool here. 15, 16 centimeters, if I recall. This is a cool rig. This is built like a brick shit house. Motorola radios are just generally indestructible because they cost $700 a piece back in '88 because taxpayers were paying for them for the most part. They were probably still are, but they definitely were the 800-pound gorilla in the police fire radio market. If you cared about your thin blue line and your firefighters and your cops and all that, you bought Motorola radios. So this is a mobile radio that was installed in some sort of commercial vehicle or police vehicle. It has 45 watts of output. You notice heavy, very nice aluminum heatsink back here. No fans, because fans clog up and die. So they built it with oversized heat sinks on the backside to make sure that it wouldn't overheat under basically continuous use. Worst case. It's got a weird connector here. This is called mini UHF. Not used anywhere except for on Motorola radios. They're easy to get adapters for, but they're just kind of cartoonishly small. But they did that because the connector was smaller. So you could drill smaller holes in your police car or your fire truck or whatever, because you'd route these cables through and do a professional install. Yeah, it's very close to a Spiky F. It has a different thread on it, and it has kind of retention things. But it is the... let's see if I have a full-size one here. It's like basically a 1/3 shrunk version of the regular UHF connector. Sorry about the cat hair there. So yeah, it's the same thing. This has the little prongs inside that will engage with a larger version of this. So it's just a miniaturized version of an industry standard connector, so they could drill 1/2-inch holes and stuff instead of 3/4-inch holes when you had to feed the coax through all the different body panels. So this is a very cool rig. I need to set up a microphone for it. The biggest thing about this is you notice there's very few buttons on here. These were not built to be what's called field programmable. It has 8 channels, so you go up 1 through 8 and back on this. So this could operate on 8 different frequencies. You'd have like a PD dispatch, and then a PD tactical, and then a PD SWAT or whatever, and then PD traffic, and just switch back and forth between the various channels that you had to talk on. But they didn't want the ability or the need for like cops and firefighters to have to know how to program these and set the frequencies in there for those channels and all that. So in order to program these, you have to hook a cable up to the modular jack, which is also the mic jack, and then use this special little circuit, which we're going to build live on a stream coming up in the next week or two, to hook it up to an old school serial port. And then you load this ugly ass software on a computer. There's a DOS version or a Windows 95 version, I think. We're going to use the Windows one to see if that works. Try to program some fresh frequencies. This was used by a ham the last it was in service. I can tell because not only did I talk to him, but he has a list of the channels. This was actually a link radio for a local repeater system. So they had a 2-meter repeater over here on this mountaintop, and they hooked it up using 2 of these radios, one at each end on a different band, to relay the audio from whatever one repeater was hearing to the other one. So whenever you talked on one of them, it transmitted through both, and you suddenly get wide range. This is a core link, or a core theory of like long distance networks that people build up with RF links point to point between mountaintops. We'll dive into a couple big ones probably in an upcoming stream, because they can get really complex, and it's kind of weird how some of them work. But there's a couple big ones, especially around the Southwest US, that you can talk literally 1,000 miles using nothing but point to point over the horizon links. There's no like none of that shortwave like ionosphere bouncing, none of that crap going on. They're all 100% reliable networks generally, really cool. So this was a link radio, missing the mobile mount. So this was used to transmit the audio from one to another. They upgraded to a newer rig of some sort and then sold this off. Price tag $30, I paid $20, because this was at the very end of the HAMFEST, and they didn't want to put this crap back in the box. So that was my other interesting radio grab. I guess I had 3 of them in total at this HAMFEST, and I'm trying to think. We've gone over pretty much everything, I think. I'm trying to think if there's any other fun stuff that I haven't gone over. Yeah, so that's my haul. That's what I ended up paying. What did I come out at? Total of like $180 for all that stuff. I'm really happy. Yeah, and half of that was that TS50, which I just love. Might fire that up in the last hour. We'll see. But it's such a cool little radio. That's going to go perfect in the Expedition. And I will try to treat it with respect, because a dead guy owned it. Weird thing is it has an 1/8-inch headphone jack. Very few radios of this class or category have the little mini one. But they really needed the space, I guess. So not much to it. You can't even computer control this. This is pretty much dedicated to be a mobile radio. So you have a DC power input. This is the 6-pin cable that goes to the antenna tuner. You hook up. You can plug an external speaker in here. You can plug your Morse code key. Again, don't normally see 1/8-inch plugs for those. So they really jammed this box full. And then your antenna jack, and then if you wanted to hook an amplifier to this, you use these ALC and relay RCA plugs. Those are just logic signals that kind of control, make sure you don't overdrive your amplifier, and make sure that it only is in transmit mode when you're in transmit mode. So I already love that radio. It's going to go perfect in the truck, and then I can have my little backpack portable rig back in my backpack, and I'll have a radio that's 10 times louder in the truck, which is super cool, and I'm super excited about. So yeah, yeah, that is the full size SO239 is the actual part number that we use, but that's a UHF full size connector. So that's pretty much the standard for anything that's lower frequency. Any shortwave radio is going to have them. Most 2-meter radios around 144 megahertz are going to have them. 6 meters, which is around 50. This summer we'll have to play on 6 meters. It's a really weird and unique band because it does have propagation. You bounce stuff off of the ionosphere like you do with shortwave, but it's also a usable local band. And the modes of propagation on 6 meters are the most popular is what's called sporadic E. And it's a scientific phenomenon where very reflective but very small patches of the ionosphere light up, So you have small and very intense mirrors that they literally do not know why they show up. They don't know how it happens. They know that there's a large season that happens over the summer, and then a smaller season that happens over the winter. So between like early May and late August, you get really good propagation on 6 meters. You can take this little radio here, which is just 100 watts, and I've talked to like, I want to say 38 or 39 different states and about 6 provinces and a couple of Mexican states too. And I've talked to the Canary Islands on there, as a matter of fact. I got that contact confirmed. That was wild. And I did all that in one summer. And then around early September or so, you just stop hearing stations because those layers don't form and you can't bounce the signals. And then around Thanksgiving or so, it fires up again, not quite as intensely. The openings are smaller and kind of even harder to predict, but it still happens over the Christmas break too. And then it dies out around February, and you don't hear shit until May, and then the cycle starts anew. And it's not related to the 11-year cycle, so it's not strictly sunspot stuff. But it's a fascinating thing to think that nobody knows why this happens, but it does. And it's not just a ham radio thing. Sporadic e-propagation, which is what it's called, is very useful for many other things. For example, probably the most common use and most famous is a system called SNOTEL. SNOTEL, all caps, because it is a government acronym. SNOTEL is the network of snow depth reporting stations all across the western U.S. They may have some in Canada. I don't know if it's the same system or not, but the U.S. for sure has SNOTEL. So they have a bunch of snow depth gauges hooked up to radios and various mountaintops. They're solar powered. They have backup batteries. They're not staffed by human beings. They're up on the most desolate, mountaintops and stuff like that, and out on these windblown plains, generally in places where nobody will agree to man the stations. They had to make these work automatically, which meant that they had to run off solar power. And with solar power, you have a limited budget of how much power you can use versus how much you want to spend and how many solar panels you want to put up. If you don't want to attend to a particular snowfall station for 5-year intervals, well, you better make sure that on a statistical average, you're still going to have enough solar panels after 3 years. Maybe they get busted up by hail or out in the high desert, dust storms and stuff like that. So they built them with redundancy and to have a low power budget. So you had these stations that needed to transmit data back to a mothership. Some big old station where they could have sensitive antennas and expensive gear and all that and have people janitor it. And that was fine for the home base station where they would take all the snowfall reports. However, they couldn't get people out there. So they had to build these things to be automated. And when you only have a little bit of power available to transmit what need to be very powerful signals, or very, not powerful, but clearly received signals, that was the operating key, because they needed to transmit data, which is harder to transmit than a voice. So they had to have, in their estimation, a relatively high power transmitter at each site that could blast out a huge ass signal to the station back in the central location and actually take the snowfall reports and take the weather reports and then send them out to the rest of the world via whatever wire services or whatever. So what they figured out was they were going to use what's called meteor scatter communications to work very close to that ham 6-meter band. This is a different mode of propagation that happens 365 nights a year, technically 365 days, but it's most active at night. And basically you have meteors that are constantly impacting the Earth's atmosphere. Every day of the year, meteor showers are just a hot spot basically, but rocks are constantly hitting the upper layers of our atmosphere. When those rocks, if they're big enough, when those meteors, if they're large enough they will create an ionized trail behind them as they burn up in the atmosphere. Turns out that at certain frequencies, around that ham 6-meter band and up to the FM broadcast band, you can bounce signals off of those ionized trails. They exist for between 1/10 of a second and 2 seconds. Statistically average, they're like 200 milliseconds long. But if you think of these, if if regular shortwave propagation is like the surface of a lake where it's kind of reflective, these sporadic E-trails, as we call them, are intensely reflected. Like somebody painted the sky with the purest silver paint they could find, and it was gone in a half a second. So the goal was to figure out how to utilize these highly reflective spots that happen every night, which is when they send their reports in for the snowfall, to transmit tiny bursts of data, like 100 milliseconds or 200 milliseconds long. So basically, in the long run, what they figured out to do, because these propagation paths are bidirectional, right? If there's a mirror overhead at just the right angle for you to talk to a station 1,500 miles away, while that exists, that station can also talk to you as you're 1,500 miles away. So it's always pretty reciprocal as far as things like this work. So what the home base does in the SNOTEL system, it has a transmitter that just screams out a carrier at like 1,000 watts with an omnidirectional antenna. So this sends signal in all 360 compass degrees, roughly equally. And this is just a carrier. And I want to say it was just at the low end of the FM broadcast band. So it was like 77 megahertz or something like that. So it was transmitting this carrier signal. Now, from what we know about this scatter propagation is it works in both directions. So all of the snowfall reporting stations have a receiver in them that's tuned to 77.25 megahertz or whatever it is. And they listen 24 hours a day constantly with very sensitive ears on that frequency. So whenever one of those meteor trails comes in and hits the right angle and makes a trail that's going to last for a half a second, because you have that continuous transmission 24/7, 365 of that carrier signal from the home base that then bounces up and it starts to bounce back down. As soon as the snow station hears that, it immediately transmits whatever data it's got saved up for the day in like 100 millisecond long data burst. And generally, because these last at least 100, like 100 to 150 at the bare minimum milliseconds, if they work at all, they're going to last that long, basically. So you're going to get that return data burst that's going to be able to use a short period of, it may have like a 200 watt transmitter up at the snow station, but it's only transmitting for like 1/10 of a second. So it just spits out rap and it bounces back while hopefully that meteor trail is still there. And then the station that is at the center, which has a bunch of receivers tuned to all the frequencies of the different field snow stations, because they're all assigned a different one. It listens to all those, and whenever it hears a little data burst, it decodes it and sends it out on the wire services and on the internet. So that's a breakdown of how SNOTEL works. Somebody's screaming back at the home office, and whenever you can happen to hear them, you say, hey, here's my snowfall report, and it bounces back, and then half a second later, that trail is gone. But that happens enough times through our whole day-night cycle that statistically it's extremely reliable, and they can get multiple reports in a day. So there's no bidirectional, hey, I got your report type thing, but on average we get enough of those ionized trails every night that the system works. And they might skip a night for a couple of stations, but generally they'll catch up. And then during a meteor shower, it's just a constant blast because we get fire hosed with them with like 10,000 times more meteors than we normally get. So yeah, that's SNOTEL. It's really cool, and I'd like to see if I can receive some of the transmissions sometime, because I want to say they have their home base stations somewhere in the Midwest. probably on some flat land, because that's the best spot for something like that. So yeah, glad I could do a little bit of education on that. 6 meters is very cool. Very awesome. Microphone is back. Pain in the ass. I'll fix it in 10 minutes. Anyway, so we've gone over Snowtown, and we'll go ahead and take a look at the rack. I think that'll be fun. And then we'll figure out what to do with the last hour, because I'm too excited about this. So I showed off my mixer last night, or last session, or the session before that. Picked up a 26 channel rack mount mixer. We fixed a compressor live on camera. That was super fun, and it's sitting here. And then I decided that I wanted to kind of move away from having a couple of crappy mixers and get one centralized location for all my audio and hopefully all of my streaming stuff. So this is what I came up with. During some even more of my Craigslist searchings, I found a guy selling what's called a crash cart, which is a mobile rack with some gear on it that you wheel around to spots in a server room and hook it up to a server and figure out why it's fucked up and fix it. This is a really, really nice rack. The ad was like 13 days old, so it was obvious that he was having problems selling it, mainly because he was up in Greeley, which is an hour north and a half hour east of Denver. So it was a fair drive, but it was on the way. So after the HAMFEST, we closed a deal on this thing, and I have a bunch of gear loaded up, and we'll see if we can go through it, because this is going to be the new base of operations for the Zcast here. So zooming out there, it is a 32 space rack. Yeah. It's on, oh, don't want to break my mount there. It is on wheels, but I'm not going to be moving it. But I've got a bunch of stuff in there already. Starting from the bottom, I've got a 12 spot trip light power strip conditioner. 10 outlets on the back and 2 on the front. So that's my power distribution for everything. Above that, this isn't going to be the permanent resident here, but this is a 2U rack with a front-facing ATX cutout. It's really groovy. It's my server box. It's a Core 2 Duo with a bunch of hard drives in it. But that's my NAS kind of server right now. I'm going to probably put a faster machine in there or get a different rack case and actually put my streaming PC in there once I go to having a separate stream box. So that little machine's there. It's chugging away. It loves being rack mounted again because I had it on top of a bucket over in the corner. Above that, we have a 2U rack shelf that I'm going to put my Yamaha amp on and get all the audio stuff in one spot there. And then I'll skip this for now. This is a 4-channel headphone amp. So this takes a couple of different line ins in the back. I can have up to 4 people plugged in headphones here. They all can have their own bass, treble, level, and sorry about that. And like main or aux send feeds here. So really cool. Just kind of nice infrastructure. Have a nicer headphone jack setup than just the one on the mixer. Above that, we have our tube composer that we fixed on camera. It runs great. Need to make up cables for the back of it, but it's totally working. Everything's happy with it. Got little twitchy needles and fake bakelite knobs. Fake light, I like it. And then above that, we've got our mixer, which we have rack mounted finally. Yes, it's a Behringer, the Behringer 2642. I had one of these. I told the story on the last stream. I had one of these. I let it go. I've wanted it for years to get its exact functionality back, and I finally found one. So you can see the green light. It's on. It doesn't have anything plugged in right now, but it will soon. So that's going to be the control center of the whole stream and actually my whole radio desk. I currently use this mixer here. It's a 6-channel mixer to route my audio to my my actual ham rigs. So there's kind of two sides to the setup here at the desk right now. But this is going to have everything on one, and I can just do switches and routing to basically send any input to any output, and have total control. So I can send particular radios to the stream and have one microphone where I talk to you and have another microphone where I talk on the radio, and we'll have the ability to do all that crazy stuff. And then at the very top of the rack, this is ridiculous because I haven't seen one of these in the flesh, and it's actually really nice. We have a rack mount monitor. It's currently showing the satellite map off Orbitron, which is being run by that server box down low. But it's a 20-inch Samsung monitor, 4x3 res, does 1600 by 1200. Looks way better than it does here on the camera. It's beautiful in person. So I'm going to be able to have like my Twitch dashboard and everything up here at the top of the rack. So, you know, that frees up the monitor that I'm currently doing it on here. A trippy effect there. And it'll give me 2 full monitors to play radio on. So that'll be really nice. So yeah, that's the rack bottom to top. Oh, one last thing that I skipped over trying to be cute. The rack unit right below here is actually a pull-out trackpad and keyboard that's hooked up to that machine. It's so cool. It's so dorky. And then you just stow it away and it's gone. So that's hooked up to the server box right there. So I think that's really pretty awesome. And the trackpad's pretty nice. Doesn't have scroll or anything. So it's kind of like adminning a server 2003 machine back in the day. But it definitely lets me click around and set things up on there. So yeah, that's the rack. I've got it set up. I'm reaching a point here where I'm kind of concerned about the power draw on my circuit here, because it's a regular 15 amp circuit. But at peak draw, I've got, as far as power draw goes, I've got, say that machine's 100 watts, and then another 50, 50, 75, 50, we're talking about 250, 300 watts possible on that rack. At least 200 watts. And then I've got my PC, which is a big old honking i5, and when we load it down, it's probably going to draw, a good like 300-400 watts, because it does use GPU power for the stream video. And then I've got that 12-volt power supply from hell, the Astron, down there. And it's got, let's see, it'll do 50 amps at 12 volts, and power supplies are generally regarded to be about 50% efficient. So that means that it could draw up to 1,500 watts of AC power if I hit it really hard. If I just draw 20 amps, which is about half load for it, 12 volts at 20 amps, that comes into the radio, so 240 watts of input gives me about 120 to 130 watts of output, and that's about right for radio. You're looking at about 50% efficiency as far as DC input power, which is actually how they used to measure this power in ham radio back in the day, versus your output, the actual RF going down the wire. And then those old linear power supplies, they crank out tons of heat, maybe not 50% efficient, but maybe 70%. So if I drew 250 watts from there, it's probably going to at least give off another 100 watts of heat. And that all adds up, and it's going to draw 350. So 500 watts for the rack and the power supply, we'll say, plus another 400 for my computer, and then just random lights and crap around here. We're talking about 1,000 watts plus of power when I'm talking on the radio, running the stream, and have the rack fired up. And yeah, so it's something I'm starting to think of. 3-phase would be sweet. Actually, my 12-volt power supply does have a switch to flip if you want to run it off a 220 line, because it's that fucking big. Because it's got like a 12-amp fuse in it, something like that, which is at 120 volts, So that means that it's set up to possibly draw 1,000 watts of power from the wall. Say you're outputting 700 watts of DC through it, 12 volts at 50 amps or so. It's going to suck about 1,000 watts of power from the wall. So you very frequently would want to run it off of a 220 line that you run to your ham shack. A lot of amplifiers, like the big 1,000 watt, 1,500 watt shortwave amps, they have to be run off of a 220 line. They will just blast out and trip the breaker on any like 120 line because of the way the math adds up. In order to output 1,500 watts of RF, you need to actually input 3,000 watts of AC power, which gets turned into, actual DC for the tubes. But you'll be drawing 3,000 watts. A standard circuit is rated for like 1875, and yeah, breakers are not precise. They'll trip soon, they'll trip late, and they trip slow, which means that there's not actually any real protection for equipment on a breaker circuit. Fuses are actually way faster to blow up and they're slow, but breakers can take like a half a second to trip on a current over. They're meant to stop fires. They're not meant to save your equipment. I have a bit of axe to grind about people that use breakers when they should use fuses in circuits. Because you can get like 12-volt breakers and stuff, and people try to get cute in like automotive setups. I'm going to put breakers in, so if I blow a fuse, I can just hit the button and go. I don't want to have to spend money on fuses. But then they blow up their car stereo amp because it gets a weird short situation, and the breaker didn't work fast enough, whereas a fuse would have. So there's a time and a place for both. So yeah, the big amps and this power supply, even if you had two of these on a single 120 circuit, they're going to exceed that. You're going to pop breakers. So you just run a 220 line to your shack, on a separate outlet, and run all your really, really big shit off that. I would love to do that. I don't even think that I have two-phase AC coming to this place. I think it's just a single wire from what I saw. It's a tiny little cottage. So we're at the top of the hour, and I've been running my mouth a whole lot. So we're going to take another 5-minute break, and I'm going to poke at this microphone a little bit, see if I can get it a little more reliable. And then we'll just kind of chit-chat and hang out for the last hour, because I've kind of gone through my HAMFEST finds and talked about the new rack and all that. Not much to see on the rack besides a whole bunch of very focused cable assembly to get it running. So by the time we stream next on Wednesday, I will have done that, hopefully. And then we'll be running through that, and I'll hopefully sound a lot better, and we can do even weirder shit with the radios here on the stream. But until then, I'm going to chill. I'll be back in 5 minutes. Everybody hang tight, and we'll just kind of hang out and maybe play a little on the shortwave bands or elsewhere on the radio as we come back. And if anybody wants to bring up any topics, you'll probably get the floor. So we'll be right back.
Code 83 is
Microphone check. Alright, good. Welcome back, everybody. Adjust my headphones here. They got all messed up when I took them off. So, we've talked about my pile of gear and all my toys. We still have that Yaesu shortwave rig that we cracked open on the last stream. Or didn't crack open, but we took a look at. We got to open that up and fix it. And I really want to not lose momentum on that. So I think the next stream will be the first session where we actually open up that radio, start to fix it. I'm going to run to IKEA and get a dedicated bench somewhere and probably move this camera over there so that we can do a little bit of surgery with a nice overhead and hopefully get that working, because this is kind of a compromise setup here on the bench with this camera. It's fun and it's great and it works, but I would really like to have a dedicated setup. And especially if I get my new DSLR setup, I'll have that setup as the main camera, and then this will be a backup or whatever. I'll figure it out. So the Yaesu is probably next on my list. Just naturally WSAD now. And then after that, gosh, I don't know what I want to work on. I'd like to do a checkout of that little Heathkit mobile rig with the flippy switches. Make sure that it's on frequency. I got the whole manual for it. So like, one thing to keep in mind, somebody built that from a kit. So they gave very good instructions on how to build it, how to tune it and calibrate it to where it's on frequency, outputs the right amount of power and all that. So I've got that whole book for that little Heathkit mobile radio. So we're going to go through that like a good little Boy Scout, recalibrate everything and bring it back into line. And then as kind of I work on the side, building up the satellite station with the rotators and the antennas and stuff. That stuff's a little harder to show on camera because it's going to be me out in the driveway with a bunch of aluminum tubing and cussing and all that. I may record some of it, but a lot of it's just kind of physical trial and error, grinding brackets and drilling holes and stuff like that. So I might make little highlight reels of what I do out there, but I don't know if I can get a camera to like stream live, mainly because we also stream in the evenings and it's fucking cold and dark out there. So I generally try to play during the days when I'm doing stuff like building antenna masts and those sort of assemblies. But we do need to build the controller for those rotators, and that's going to be a little bit of electronics homebrew type stuff. We're going to need to hook some relays up to an Arduino or something like that, and then get like a power supply transformer because those motors take AC. So we're going to be building a nice box, and I'm going to put a little LCD panel on it to show the current heading and elevation and stuff, and figure out how to get it to talk to a computer through a serial port and stuff like that. So that's going to be kind of the homebrew project coming up over the next month or so. So two-pronged attack. We're going to try to fix the Yaesu up, and then keep momentum on building the satellite station up, because by the time summer's around, I'll have had my new radios, that ICOM 9700 and 7300 that I keep talking about. Those will be both out, and I can go buy both of them, and that's really when I want to start to play with the satellites and that sporadic E on 6 meters and stuff. That's going to be a lot of fun here on the stream, but I need to get the station set up before then. So I've got a bit of a clock on all that. So I've got a couple of projects, that I want to do. So really, it'll be more of get the satellite station set up in the next 3 months, and then in our spare time, if we're stumped or something on that project, we'll fix that older FT757 Yaesu up, and then I don't know what to do with it. I already have too many radios, and I keep buying them. So I think I want to sell it. We may throw it on eBay, and then all the proceeds from that radio, remember I got it for free off of Craigslist, are going to go back into the Mattyzcast fund, and I'm going to buy a bunch of electronic kits and smaller things, basically, to give us more of an ongoing, hey, maybe on Wednesdays we'll like always do a kit build, and I'll do a giveaway for that to, a sub or a follower or something. And then on Saturdays, we'll like work on our, fix it DIY projects and like kind of homebrew some stuff then. We'll see how it breaks up. But yeah, so that's my approach. if any money comes to the stream, just so everybody knows, it gets put right back into the stream. As far as test gear and components and stuff like that. Every dollar that goes into the stream, at least for now, when I'm making $1 million a year, it might be different. But for now, all the money that y'all kick me through subs and bits and whatever goes straight back in. So just want to make sure that's clear. I'm not buying any, I'm not buying weed or 40s with your money here. If you do decide to kick me some. So yeah, because that's a thing now, because I'm an affiliate and it's weird, and like I had to fill out tax forms and I technically have a second job and it's freaky. But I couldn't think of a better side job. So glad the stream's still going good at 2,900 kilobits. 47 dropped frames. I still think something's up with my cable, but I can't quite figure out what. So anyways, yeah, it's very nice, and I'm actually way past the 50 follower floor. I think we're up to 62, 64 people give a shit about this stream, and that's so exciting. So I hope people are having a great time for sure, because I love it. Tell your friends. Feel free to raid me, and I'll raid back. So yeah, I don't know what I'm doing. I'm just kind of figuring this out, and turns out that it's really, really good. Thanks, Kat. My number one cheerleader for sure. Couldn't do it without him. Microphone, you suck. I changed adapters even, and it didn't help anything. I don't know. Doesn't matter. After this stream, I'm going to be switching over to the new mixer and all that stuff. And I won't have to worry with any of that bullshit anymore. So I'll be excited for sure. Damn. Okay, I gotta call out Bobby. I did not see those 3,000 bits. Thank you, dude, so much. Oh, I'm so pumped. Wow, amazing. All right. I don't know if I can do a contest for the biggest bit contributor or whatever, but you'd win for sure. No, that's beautiful, dude. Thanks so much. I appreciate it. Anything coming in is just amazing, and not even something that I planned for. I just appreciate Twitch for just giving me the microphone and the platform. The fact that I might get a few bucks to, be able to buy some like test probes now and then or something like that is like, holy shit, that's so much better. So yeah, really awesome. So I figured because it's a nice evening hour and I don't have too much to show and tell, and I don't have any real projects that I've started right now, I figured we'll just play radio a little bit and see if we can listen to anything interesting or pull up any cool stuff. Take a pop down to the data bands and see if we can get some little deedles and beeps and boops. Switch over here. That's funny. Yeah, I'm watching myself there. Okay, that's better. And let's see. Let's take that monitor off. That's a good question. We should check and see, Verge. So there's actually a 40 meter frequency. 14.230 in the 20 meter band, higher frequency, is active during the days, but it's kind of died out at this point, just because it's late in the day. But we're going to check the 40 meter band and see if anybody's on and hanging out. So in order to do that, pull in on the radio. Hey, not bad. We need to go to 7.171, and we're lower sideband here. So there's two halves to an AM signal. Upper sideband cuts down the bottom one and only transmits the top one. The lower sideband only transmits the lower frequency one. So we're like the dark half of the mirror here or whatever. And that's just due to kind of convention. It was easier to build radios back in the day that used clever circuitry and math to transmit upper sideband on higher bands and lower sideband on lower bands. Because we have fancier, newer radios now, they can do LSB or USB, as they're called, on either band or on any band. So it's arbitrary now, but by convention, down here on 40 meters, we usually use lower sideband, and that holds for any bands, 80, 160 meters, all those all operate with LSB just by convention. You can transmit with the upper sideband only, but you'll sound super unintelligible, Donald Ducky to people, and they may get annoyed just because you're being the weirdo. So let's take a listen here. We're on 7171, and see if maybe we can rouse somebody. So we're gonna have to do a little bit of tune-up here. Bring it over to the meter here. You may remember what we have to do with this. We have to minimize the reflected power by turning these two knobs. So we're going to do that now and kind of tune the antenna system up and see if we can get things operating right, and then we will make some transmissions and see if anybody's out there. So I'm going to go there, and then we hit transmit on the radio. And we set this forward power here. And that's our reflected power. That's not very good. So we're going to try to minimize that needle. And these controls interact a little bit. I think it's going to be down here somewhere. There we go. That's looking pretty good. And that's a well-tuned antenna system. So we can now hit transmit on the radio without blowing things up. I'll actually leave things on the power meter. So it's on the 200 watt scale, so 100 watts is about 2/3 of the way, and then 200 watts is all the way. We're not going to transmit the full power on this because you don't want to blow up the radio. But you do run it at like 70 or 80% or so for these data modes. So let's see here. I need to put that over there. And I'm going to transmit a test tone. That looks just about right. So we've got about 110 watts here. This radio will do like 130. So that's right about where I want it. I don't want to blow it up too much. But that will give us some good juice coming out here. So let's see here, and let's go ahead and pick out a nice picture to send. I like Red Rocks. Red Rocks is a good first one. I'm redoing all my templates, Burge, by the way, because I installed a different version of Adobe products. And they can't open any of the stuff that I made on the 2019 demos. So I need to redo all my graphics and stuff. So all I have now are like the rendered AVIs and MP4s and stuff. So I got to start over, but I know how to make stuff, and so I'm gonna probably tweak and improve things, and then crank those out. One other thing that I want to do is I want to make sure to do my main Mattyzcast logo in Illustrator, so I can export a vector, because there are laser cutting shops that will cut me my logo out of like a piece of like masonite or something, and I'm going to paint that black and backlight it so that it glows kind of like my on-screen logo, and then I'm going to put it up in the big black window behind me. I think that might be fun. Maybe figure out some like channel commands to have people tip bits to change the light color or something like that. That might be fun. We'll see. We'll see what we can figure out. So let's go for... I like that one. It opens up the sky a little bit better. I'm going to go for Scotty 2. This takes about 73 seconds. And we're transmitting a 320 by 256 analog image here, for those of you that need a reminder as to our modes. So let's crank it out and see if anybody can hear us tonight. A little bit past the halfway point. You can really hear it change when the pattern comes in with the big white text, huh? Just checking the meters on that new power supply just to watch them twitch a little bit. It was drawing a good 18 amps of current there the whole time through. So 12 times 18, 192 watts of power input for about 100, 110 watts of output. So that 50% rule on radios really holds tight. It really does. So let's just hang out here a bit, see if anybody else is playing slow scan on 40 meters. Honestly, kind of a small chance, but we'll see. We'll see what we can do here. There's a lot of noise on the band. The shortwave bands were super shitty over the past week. They just came back yesterday, basically. I guess there was some sort of coronal mass ejection or something. Whenever that happens, it generally kills the shortwave band, so that you just hear nothing but really loud static in those stations for a few days until kind of the charge dissipates off of the earth and all that. But we got slapped by that a few days ago, like Saturday, when I tried to stream and failed. Hell, it could have been due to those bad conditions. For all I know, we'd get a freaking solar flare or something. Anyways, I didn't even turn these radios on over the weekend because they were so dead. But things came back yesterday. I've heard lots of people on today, so there's a fairly decent chance. Better than 2 days ago, for sure. We're going to bet that nobody had their slow scan program set up there, and they can hear us. They just had to fire up and wait for us to do another one. So, I like this one because it sounds really cool. It's got interesting patterns. And what's our pattern going to be? We just need little CQs. Oh yeah. That looks pretty good to me. Alright, let's keep it on Scotty 2 and let's just fire it off again. Slow scan TV transmission. If you're new to the stream, if you want to record things or come back with a Twitch clip, you can actually run the audio through what I transmit on the stream through a slow scan TV decoder and pick up my photos, as well as the photos of everybody I happen to talk to. Hopefully somebody will show up and we can actually have a contact here. So, having said that, let's fire it off and go. Hear the pure black now. And then every fourth line, I know that because I made the graphic, has a slightly different color. You can hear the pitch of those fourth lines change, every color change. Almost done. And we're done. And if you heard that little dee at the end, that's just basically a short data burst that tells everybody else's slow scan programs what mode you're transmitting in. And we just by convention transmit it at the beginning and the end of the transmission. Called RSID. So we'll see if anybody is out there to rock and roll slow scan. I'll give it a minute or two. And then I'll try the other antenna for this band. So I have a horizontal and a vertical antenna. We're on the vertical right now. There's a good chance that there may be somebody that will hear us better when we're on the horizontal wire that can't hear us at all now. So we're going to try a couple more times on a different antenna after we wait a minute here. Also check while we're waiting. Yeah, sadly the ISS is not anywhere near and won't be by for... Let's see what the predictions say. Yeah, we can get out on at 6:26 a.m. and catch the ISS bright and early. I think they're still doing slow scan TV because there was so much popularity a couple weeks back. But I'm not going to get up at 6:26 a.m. So. Alright, we waited a couple minutes. We're going to go over to the other antenna. See if we can hear anybody different there. And the noise level is usually a lot lower on this one. And we're going to do a little bit of tune-up jiggle here. Get that needle as low as possible. Looks good to me. Alright. And let's give it another shot. Let's find... This one's always good. It's pretty. Let's go. One more time, Scotty 2 on the horizontal wire. See if anybody else can pick us up here. Downtown Denver skyline in the back there. This is the Lakewood Water Treatment Plant. I can actually hear the fan of my radio through my mic. Alright, let's give that one a minute, see if anybody's out there. You didn't see the meter twitch because I had it on the reflected power setting, which shows how bad the match is between the antenna and the radio. And since we did the little knob dance there and got it down to 0, you don't normally see that needle really move when I had the switch flipped like that. Let's wait another minute. Let's pick out our fourth and final picture to send. Call to Motherland is always good. A little bit of Soviet propaganda to wrap it up. If this doesn't pull them out, nothing will. And I might run them off with this one. No response. Let's go ahead and send this one. I got it on the power setting now so you can see me crank it out. There we go. Good 110 watts. I can output about 20% more peak power now because that power supply under the bench is so much bigger than the previous one I had. The one that I had it's going to become my bench power supply because it has adjustable voltage on the front with a knob, so I can make it 5 volts for little, you know, transistor circuits or whatever. But it wasn't very good at full power crank like this. Like I'm not even 100% stressing the radio and it's putting out 25-30% more than I used to be able to on that old PSU. Makes a big difference. Gotta feed the DC to these radios if you want the RF out. It's about 70%, 60 to 70%. So yeah. Idle, it's gonna do about 50 watts of just like idle. If you have nothing hooked up, it's about 50 watts of heat dissipation, and then it kind of ramps up from there. It's not strictly linear, but generally, yeah, it in the bottom half of its load range, it's about 50 to 60% efficient, and then in the top half of the load range, it's a little bit better, 60 to 70. Well, actually, this is the same corner that has my furnace, so heat's heat, and since I use electric heat half the time anyways, I don't really care. Summertime, though, is going to be very different. I'm seriously considering getting some sort of outdoor rack setup for this, and then running the power supply outside on my porch, which is a covered enclosed porch, and then running big 12-volt welding cable basically in here, like 2-aught gauge or 4-aught gauge, and then run that into here so that thing's out there not heating my house while I'm trying to fight it with an air conditioner. So we'll see how that goes. We'll think about it. It may not be that big of a deal. We'll see. I would love to have a water-cooled power supply, though. I guess I could do it with that if I figure out how to turn those heat sinks into heat exchangers. But it might not be worth the technical challenge. Alright. I don't think we have any slow scan TV hits for tonight, sadly. We tried. We did send out the RF, but nobody that cares about slow scan was listening. It happens. So yeah, I'm gonna just poke around and see if there's anybody interesting talking tonight. For now, I'm gonna switch back to my vertical antenna.
Let's pick up this contact real quick. I'm not gonna be here very much longer either, gentlemen. Couple of notes.
So just skip down. I'll rub your dough. So let's pick up that contact real quick. Contact, go ahead.
Can't really hear the other guy here too much. I'm bored. Let's go.
I can hear you. But the fan's up and down right now. See what's up?
And I do have the primitive 2001 technology noise reduction on right now. I turn it off. You can tell the level comes back up, but the problem is that as you turn the knob up, you get that super watery, like, early cell phone sound. This thing isn't even usable at like anything above like 10 o'clock on the knob, but sometimes just a little bit is worth it. So he's calling CQDX, which means he doesn't want to talk to me or anybody else inside the US. That's fine. Some people like to chase DX and do stuff like that. I don't really care. Doesn't really hold my interest. DX, distance contact, or something like that. It's somebody in a different country, basically. With the exception that Alaska and Hawaii are counted as DX contacts in most contests, just because they're so freaking far away. Not too many people on the 40-meter band tonight.
And that's a distance of 2,356 miles from me.
Sometimes I like to flip antennas just to see if he'd be picked up better on the other one. Very frequently that's the case. I try to keep an ear out on 7200 because that's where the trolls live, largely on that frequency. They'll get on and they'll say some really shitty things. And I'm not trying to listen to have fun, but I do collect recordings of them, and I periodically scan the FCC records to see if they've been slapped or accused of anything, and if they do, I'll send the logs in. I've already done that once with one guy. His call is W6WBJ. He's a super shitty guy that harasses people in a racist manner on the shortwave bands. So many people hate him, but the problem is that he's an attorney by trade, and he knows how to manipulate the FCC. It took them 10 years to take his license away. Really ridiculous.
Very solid amplifier.
But I think he's off the air now, finally.
No big commander or anything like that, you know, of course, but does very, very well for me.
So this is what's known as a state hunter net. This is one of the ones where you log on and you check in, you say, I'm in Colorado, or I'm in Massachusetts, or whatever. And then they just make contacts back and forth to try to get, like, worked all states awards and stuff. Not really interesting to listen to, but it's a great way to find out who you can hear from, you know, various areas.
And it is 133 feet of wire up there into just coax.
It's a ham radio. Let's talk about ham radios.
And going to a dense.
Yeah, I think the worked all states nets are pretty cheaty. I've heard them do obvious, not allowed by those awards things on the air. Yeah, with my own 2 ears. But everybody just kind of defends them and says, look, they're doing their thing. They stay on one frequency. They don't bother anybody else. Just let them do whatever. I was like, okay, if you want to make the worked all states award eventually worthless, you know, if it doesn't mean anything, if you can have people relay, you know, like all the signal reports and stuff, then it doesn't mean anything. But if you want to do that, sure, go ahead. So it's not like a FCC violation thing. It's just they're being kind of shitty thing.
And it works pretty good. I'm using a voltage balance instead of a current balance. Okay.
And this is going to be some really dry, boring chat about the radio stations.
They're 48 feet high.
We'll spin around, and if there's nobody else, maybe we'll come back. Yeah, they just totally bullshit it, and they just like, oh yeah, I totally worked this guy in South Dakota or whatever. Heard him great. Great signal reports both ways. Nobody really tracks it down or chases it. You know, it's not like I'd record and try to rat them out for it, because everybody knows they do it, but they keep it themselves and don't bother anybody else, so it's whatever. Yeah, 2 meters can be super shitty for that. People get on, especially like when they get drunk in the evening and like stuff like that. Ooh, it's not good. Not good at all. Around here, it's pretty tame because everybody knows that the repeaters have such a wide coverage area here in Denver that like there's a good chance that like 400 hams are going to listen to you. VE7K FM. Yeah, do a Google search on that. Victor Echo 7 Kilo Fox Mike. Horrible, horrible dude. And that's all on Industry Canada, because they're the FCC up there. And they wouldn't pull his license forever. I think he still has his license. I don't hear him on much anymore, though. So, who knows? It's a guy sending some very slow Morse code. I don't think he's talking to anybody. I think he was just calling CQ. Down here, 7100 to 7125 is slow speed Morse code. There's another guy in there. It's the old guys that are very, if you only can send it 5 words a minute, and if you need some repeats, they'll work with you and hang out because they're all about just the joy of operating Morse code. So it's a cool gang, and a lot of those crystals that I have that I showed earlier are so I can run a transmitter on frequencies like this. Because you can make a little basic transmitter in like a cat food can or something like that, goofy, and then hang out, just with a straight key and send slow code in this band, and they'll totally hang out with you. Cat 5 asks, 14313 still a thing? Yes, a little bit. Maybe a couple days a week I'll hear people fire up on there. It's not nearly as bad as it used to be. It used to be every day, all day, V7 KFM, and the rest of the trolls would get on 14.313 with their 1,000 watt amps and their huge antennas 150 feet up and just blast hateful, dumb shit all over the airwaves over and over. It was chaos. People would try to jam them, so you'd have 5 guys yelling and hollering and screaming while he was playing shit on a tape loop or something like that. Like, he'd play like Rolling Stone songs and then talk about like how Jews were genetically inferior for a while, and then go back to some silly recordings and like then play 10 minutes of just like horns.a for something like that. Really horrible dude. But yeah, search V7 KFM for the whole story. Some dudes just get off on that and they figure out that the FCC or IC for US and Canada respectively don't really, like, they have teeth, but it takes years for them to get their jaws moving, and you have to have complaints and they have to research it, and there's all this due process. I'm not saying there shouldn't be, but I'm saying that that's what they take advantage of. And specifically that other guy that I was talking about, W6WBJ, that's how he was able to keep his license for 10 extra years, because he kept tying up the FCC. He'd actually file motions for continuances and like ask for discovery of this or like discussion of that. And the FCC is used to people just saying, I'm sorry, here's your $15,000 fine you gave us. Whereas he gamed the system and just dragged the process out over and over and over. And finally, last June or July, I think, we were looking today, in W6WBJ, he was licensed up until now only because he put a renewal in for his ham license, and the FCC held on the renewal. They refused to renew it, but they said they were looking at it. And in that particular case, according to federal code, you keep your current license until they've made a decision. So he then abused that process and filed for continuances and asked for discovery of this, that, and the other to just be a legal troll and stretch it out by 10 years because he knew he was going to lose. There was too much evidence. Like, there's like tapes of him just like talking about put Jews in the oven and just horrible, just like racist trolling that he loved doing and loved getting away with. And they finally had enough evidence that they're like, look, after this investigation is over, your license is gone forever. But he knew how to stretch that process out for literally 10 years. But in June of 2018, they finally took his license away, and we all said bye, because nobody that actually loves radio or enjoys this hobby likes stuff like that. It's just horrible. So those guys, they need to go away. But most of the jammers and most of the really offensive types, to put it very, very upfront, are of a much older and whiter and more Trumpy generation than the people that I like to see come into the hobby. So the sooner that those old, like, racist boomers that do key up the microphone and spout all that. I'm not saying all old hams are bad, but I am saying that all the ones that, like, go out there and start Sieg Heiling on air and stuff like that and jamming and being offensive and not wanting to play radio because they want to play radio, I'll be glad when they're gone. So I think most sane people are on the same wavelength as me. There's a little bit of a debate whether or not to completely shut down all of those kind of trolly offensive operators, or whether it's better to basically try what we can do to corral them to one specific frequency or one repeater and kind of containment zone them. That's a big argument for...
Maybe not so was yours.
There's that State Hunter net. That's one big argument that people use to defend the. There's a repeater in Los Angeles up on Mount Wilson, I think, but it's in the LA area and it transmits over the whole city, and it's 147.435 megahertz. And the 435 repeater is notorious for having just a bunch of profanity and people jamming one another, and it's kind of like a Channel 19 CB Cowboy Hell World. And it only happens in the LA area. There's like 30 repeaters, but it only happens on 147.435. And a lot of people say, well, that's because they haven't shut down 435. They can go there, get it out of their system, say their F word a whole bunch of times and all that, and they won't go on the other repeaters. So we'll be kind of ignored from them, or by them. And that's an argument too, but it also sets precedent that if you get enough kind of shitty radio operators in a little group and say, hey, we're going to just take over this frequency and take over this repeater. And the problem was that originally 435 was not intended to serve that community. They basically showed up and took it over and said, hey, we're going to just basically shout horrible shit here 24/7 and stuff like that. And the original owner was like, you can't use my repeater. Like, I don't want you on. And he kicked everybody off. And in theory, if you get kicked off a repeater, you have to, and this is actually in the FCC regs, if they ask you to leave, you have to leave. They obviously did not leave. The guy didn't want to admit defeat and shut his repeater down, so he took a different approach and was like, I'm going to sell the tower release and the equipment to somebody that wants to deal with these assholes. And sure enough, 3 or 4 of those assholes got the money together, bought the repeater, and basically took control over. And at that point, people started to look at the FCC. What options do we have to shut these guys down and stuff? But a lot of people said, hey, look, we've had problems with these same 12 dudes before. They're horrible once they get on our repeaters that we want to use and talk on for actual friendly stuff. They just ruin it. And ever since they hung out on 435, we haven't heard shit from them. How about we do nothing? And that's kind of where it's been for 20 years or so, from what I understand. They're not really aggressively trying to shut this community down or anything. There are actually, in one Seattle area repeater, they have the coolest thing. It's pretty much unique. I haven't seen any other repeaters do this. But instead of controlling access with a subaudible tone or whatever, they've got a bunch of computer gear hooked up to their repeater input, the side that listens for other stations. And you literally have to register with this repeater. And how they ID you, so you have just all different makes and models of ham radios out there that operate on the possible repeater frequency. But what they figured out is that every time a radio switches from receive to transmit, for 50 milliseconds for the start of the transmission, it emanates energy in a particular pattern and a particular profile, basically. It's got a sonic signature, but it's up in the radio frequencies. And it turns out that a lot of these are basically unique among ham radios. And you can establish, if you have a database, if you figure out how to do math on this, yes, it is literally called radio fingerprinting. Good call, Butcher. Thank you. But yes, that's what they call it, or RF fingerprinting. And in order to use this repeater, they have to register your radio and put its profile in its computer database. And then every time you hit push to talk, it looks at your transmitted signal and compares it with all the entries, and you basically, if you're on the whitelist, you get to use the machine and it transmits your signal. Otherwise, the computer ignores it and says you can't talk. So it was basically proto device registration. There's a lot of new digital radio networks that have radio identity as part of its kind of design and its protocol. So every radio has a serial number, basically, that it transmits every time it talks. So that's simplified a lot of that stuff. It's really easy to kick a particular handheld radio or mobile radio off of one of the digital networks. You just say ban this ID and boom, they can't access any of the repeaters or anything like that. But back in the analog days, you couldn't force people to transmit an access code every time they keyed up. But they are crazy RF engineers, and they're like, let's see if the transmitters have particular signatures. And sure enough, they did, and they built their system off that. And it still works to this day on that model, as far as I know. Nobody else has really undergone that. But the only reason they implemented that is because Seattle was getting a problem kind of like what LA had with the 147.435, except nobody wanted to create a safe haven for all the trolls. So they just said, let's boot them off and let's figure out how. And they figured out the radio fingerprinting thing, implemented that, and it turns out it was a raging success. So for every different radio you want to use on their network, you have to key that radio up and register it in their database. And it seems creepy at first, but this is like a club repeater, so everybody's like a dues-paying member, or at least a friend of the club. So yeah, it's not really accessible to just random people that drive through. It's kind of a closed machine, but you know, as long as you play by the rules, they'll let you on. And as soon as you're a jerk, they can ban your radio and say you can't use this repeater. Goodbye. It's a really neat approach. And it was, you know, like they did that in like the early to mid 80s, from what I recall. Like they had some very crude computers hooked up to like figure all that out, but they engineered a solution. I'm going to take one more spin through the bands.
I'm going to try to make the trip and go see what they have out there on the tables, and maybe I can find a good deal on some telescopic poles or something to get some antennas up in the air a little better.
Gotta have the poles.
Playing with the antenna side of things. I used to have a full wave loop, 160 meter loop, up at about 35 to 40 feet.
That'd be about 550 feet of wire.
Measured from, right? And that thing performed great. Loved it. But got to looking at it one day and had some people over for a little barbecue kind of thing, and was looking out there going, man, this thing's kind of ugly. So I took it down. Biggest mistake I've made yet.
Let's see if he squirts out a call sign. We can look him up.
I don't care how ugly they are. Those things work quite well. Worked a lot of stations with that thing, and ended up getting the 05 vertical, and it's not the 43 foot version. It's just I think it's a 32 or 33 foot. So it's just a monoband right here for 40. It loads up okay using a tuner for some other bands, but
it's basically the same antenna that I'm using right now,
and it works much better. Between 35 and 40 feet, not really high, especially if we're at full length.
Can't really hear the other guy. Moving on down the dial, up the dial. Some old ham rigs had it backwards. And spin it down to go up. Yeah, that guy is maybe in his 50s or so. You don't hear some old men. Let's go down to 75 meters for a bit. Wrap it up with some 75 so you can hear the absolute oldest grandpa of the gang. Should be fairly busy.
We're going to be here a few minutes if you want me to get your whole call. I'm struggling, my friend. I'm sorry.
Well, if he can't hear him, we can't hear him.
I'll stand by just as clear as a bell, but when you say your call sign, it just doesn't come through.
Yeah, that guy was mad for some reason. And yeah, there's a huge connection. Yeah, I'll ramble about this to wrap it up. There's a huge connection between ham bands and the kind of people you'll meet on there and the personalities you'll come across and stuff like that. It's very, very important to understand that in order to operate on these lower frequencies, like I'm blessed here because I have a landlord that doesn't give a shit, and I live on a multi-family property with like 6 little houses, and they're all owned by the same property manager. So I have the physical ability to put up a 135-foot long antenna, which is what I have for this band here. It's actually resonant. I am, in that regard, very blessed. I'm a 1%er because I'm a renter that can put a huge long antenna up. That doesn't happen anymore. And, you know, when you have, like, kids that want to get into ham radio and they want to get into these shortwave bands, you know, like my 40-meter antenna is a 30-foot pole sticking straight up off the chain link fence. My 80-meter antenna for this band is a 135-foot wire. People can't put that up unless they have a detached structure and ideally they own the property. Well, guess what people under 40 like can't do these days? They can't buy a house to play radio on. You know, at best they're like still living with their parents who have a nice big old boomer house with tall like oak trees. But there's all like I've heard of a lot of like hams like under 30 that they stopped playing radio when they moved out at age 25 because they didn't have any property to. They had to move to a cracker box apartment, and you can't play on these bands if you're in a like a multi-family dwelling, if you're in a like an apartment complex, if you're 17 feet up in the air or 17 stories. That's a little more impressive. It's a huge problem. So as a result, the people that have the big signals on the 75-meter band are the people that can afford 100-foot towers. And in order to have 100-foot towers, you have to have them on, 20, 40 acres of land. You're not putting these up in a city. So you're kind of coming to a situation where if you can afford the necessary environment, which is a large amount of open land out in a rural area that's not affected by like building codes or height limits and stuff like that, those are going to be the voices that you're going to hear when you just spin the dial, especially on like any compromised setup, you know, like a portable shortwave or something like that. You're going to hear the people with the biggest signals. The biggest signals come from cornfields. The people that live in cornfields are huge Trumpies. They're mad at the world, and they're 75 years old. And that's what this band is largely dominated by.
With the group, after 9 o'clock, and that'll work. Because what we've been trying to do there, Jerry, is we've had so many people in here, and the influx of so many people, we decided, okay, we'll see if we can get the Friendly Bunch guys to have a number to have, just talk amongst themselves between...
Too many people showed up to talk with them on the radio, so they decided to change frequencies.
This is part of the training program with the kids.
These guys are actually cool chit-chatters. They do a trivia net most nights of the week, so it's really cute. You're supposed to not have a computer pulled up, and they ask, like all kinds of dumb boomer trivia, like, Elvis's first gold record, or what year was the Mustang first produced, or, what was Sally Field's third film, stuff like that. And everybody pipes up with their guesses, and then they're like, does everybody agree with so-and-so? And then they say yes or no, and then they say, all right, you got it right, or no, you didn't get it right. It's really cute and really dumb, and it's just a bunch of old dudes just kind of keeping their memories active. And they don't harm anybody, and it's nice to listen to. These guys, around the holidays, will take turns playing Santa on the radio, so all the other old men can get their grandkids around and say, hey, you want to talk to Santa Claus? Because you can run third-party traffic over ham radio as long as you say you're like handing off and they use your call sign. So they'd get their little grandkids over or whatever, nieces and nephews, and hey, you want to talk to Santa on the ham radio? And some old guy would go, ho, 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 I heard you've been a good boy this year, and stuff like that. And I guess it's a huge hit with the kids. So the people on this band, they're not heartless, they're not like straight up offensive and evil. they're just like old, and they're like really back in like set back in like the last half of the 20th century. But they can do some really sweet things. And yeah, if the Twitch stream, God willing, is still going around Christmas, we will definitely tune into the holiday nuts. And then on Christmas Eve, they all load up on 3916 and they play Ham Radio Santa Tracker, and they all call in fake reports of, I think I saw, like a streak of reindeer light and a couple of sleigh bells above Omaha, Nebraska, and they'd fake like Santa reports so everybody else can have their grandkids come by and listen. It's like, oh, we're tracking Santa. It's like the NORAD Santa thing, but Hams actually did it first. They started doing that several years before NORAD did their little stunt. Anyways, so yeah, the 75 meter, in conclusion, it is a land of contrasts. I don't generally find myself talking to too many people on this band, but it's really nice to listen. You can tell a lot of them have really good audio, strong signals. So if they want to just chit chat about kind of, heartwarming, chill stuff, talk about their old tube transmitters, stuff like that, I'm all about it. But it's once they start to get in bitching about Obama and Hillary, I immediately spin the dial. And that's all I can really do at this point. That and wait for them to not be around. And then you all and the rest of the crop of people under 50 that are interested in ham radio will get your licenses, and we'll get you set up the stations and get you on the air, and by God, we will overwhelm them with sheer numbers. And that's my long-term, lifelong goal, is just to try to shape ham radio a little bit more towards the friendly, more humanist side of, enabling communication between people, rather than it being the haven of the old rich white retired Republican engineer. So I'm going to go ahead and wrap it up because we have rocked it for 3 hours. I'd like to sincerely thank everybody that's subscribed, that's liked, that's thrown bits, that's cheered on with the emotes in the chat. I love it all. We had a great time. As you can see, we have quite a full shack. We have months of projects ahead of us. I'm going to work towards organizing, and we're going to get started Wednesday night at 7 p.m. Mountain. That'll be 0200 UTC. If you can't do the math, learn it and figure it out, because you're going to need it on this stream anyways. So yeah, we'll go ahead and say goodnight to everybody. Thank you all for tuning in, and we'll see you in a couple of days after this special President's Day session, and start to play with this pile of HAMFEST stuff I got. So yeah, thanks again. Have a great night, and we'll see you in a couple of days.
Thank you.